Let's talk about full adders. We know full adders take 3 inputs and then 2 outputs, and the 3 inputs are A, B and C. Here the C is the carry in. Okay, the carry in. In some textbooks it's shown as C in, and it's sometimes given as C. And the outputs are sum and then the C out, or the carry out. And the sum is given with the Boolean expression A XOR B XOR C. And the C out is given as AB plus BC plus AC. Now, we are going to draw the full adder by using only NOR gates. Okay, if we rearrange this based on the max terms that we normally do, okay, by using the max terms that we normally do, it takes actually 12 NOR gates. It takes 12 NOR gates to come up with the full adder. But since we are trying to optimize the circuit, we use a special industry design to study here. Okay, and I'm going to explain it to you step by step. So keep up with me. So we have the A and B first. Okay, we have the A and B signals first. Let's talk about them. And we are going to send them through a single NOR gate. We are going to send them through a single NOR gate. And that will result in A plus B whole thing bar. Okay, this is a very important signal. So we are going to keep that line extended. Then we are going to send A through a NOR gate. Okay, we are going to send A through a NOR gate along with A plus B whole thing bar. So we will get A plus B whole thing bar. Okay, now I'm going to simplify this so that we don't have to use this in the future again and again. So we know we have A plus B whole thing bar. And this can be given as A bar into A plus B whole thing bar, and that will give us A bar into A plus B. And if I simplify this, I'll get A bar plus A bar B, which is equals to just A bar B. That's it, because A bar is equals to 0. Okay, similarly, okay, so this is actually A bar B, that's it. This is actually A bar B, that's it. Similarly, like we did here, we are going to send B also through a NOR gate. We are going to send B also through a NOR gate along with A plus B whole thing bar. Okay, which will actually result in, if we are sending B and A plus B whole thing bar, it will be B plus A plus B whole thing bar. Here we have A, here we have B. That's the only difference. Then the output will be, well, it will be B bar A. That's it. It will be B bar A. Now we are going to send these two through another NOR gate. So I will get A bar B plus A B bar whole thing bar. And this is XNOR gate, ladies and gentlemen. Okay, this is XNOR gate. So we can give it as A XNOR B, or for our understanding, we can give A XOR B whole thing bar. It really doesn't matter. Okay, now only we are going to introduce C to the system. So let's draw C here. Okay, Okay, and C is the input that comes like this. Okay. Now what we are going to do is we are going to send this and C through a NOR gate. Okay, we are going to do that. So that will give us, C into A XNOR C, not C plus A XNOR B whole thing bar. Okay, C plus A XNOR B whole thing bar. Okay, and this can be given as C bar into A XNOR B. Okay, XNOR B whole thing bar. So that is actually A XOR B, right? Yeah, we can simplify that. Okay, we can simplify that as A XOR B. Okay, so that will be A XOR B. That's it. Very simple. This is also a very important input line, so we are going to keep it open. Okay, we are going to keep it open. We are going to send C and C bar dot A XOR B through a NOR gate. Okay, so that will give us C plus C bar into A XOR B whole thing bar. Okay, we have to rearrange this. Okay, because that looks a little bit big, so we have to rearrange this. So we have C plus C bar into A XOR B whole thing bar. This can be given as C bar into C bar dot A XOR B whole thing bar. Okay, this is what we have. Now we are going to break down inside even. Okay, De Morgan's law is very important here. If you don't know De Morgan's law, I'll attach the video at this point, so you can go and watch and come. So C double bar into A XOR B whole thing bar. So that will give us C bar into C plus A XOR B whole thing bar. Now if I expand this, I'll get C bar plus C bar into A XOR B whole thing bar, or I can say it's XNOR, and C bar will cancel each other out, so I'll get C bar into A XOR B whole thing bar. Okay, or I can say A XNOR B. So I will write that down here just to be safe. So it will be C bar, okay, C bar into A XNOR B. Or I can say it as C bar into A XOR B. It doesn't matter, both are same. XOR B whole thing bar. Doesn't matter, they both are same. Now what we are going to do is, we are going to send intermediate output C bar into A XOR B along with A X NOR B. Okay, we are going to send these two through another NOR gate. We are going to send these two another NOR gate. So what will it result in? Well, here we have the C bar dot A XOR B plus here we have A XOR B whole thing bar, and then finally the entire thing is covered with another whole thing bar. See, if you look carefully, here we have C and here we have A XOR B whole thing bar. Here we have C bar, here we have C bar, here we have A XOR B, here we have A XOR B. Okay, and the output was C bar into A XOR B whole thing bar. Okay, so what will happen if we change the C with A XOR B whole thing bar? Think about it. If you think about it, well, we will get A XOR B, okay, A XOR B into C. We'll get A XOR B into C. That's it. Okay, we'll get A XOR B into C. If you don't understand, we can simplify that also. No worries. So here we have C bar into A XOR B plus A XOR B whole thing bar. Instead of A XOR B, I'm going to say that X is equals to A XOR B. Okay, so this can be given as C bar X plus X bar whole thing bar. So that will be C bar X bar into X double bar, and finally it will be C double bar plus X bar into X, and it will be C X plus X bar. So I'll get C X, which is C into A XOR B. That's it. Now we are going to send these two through another NOR gate. Finally, we have the eighth NOR gate. Okay, we have the eighth NOR gate, which will result in C bar A XNOR B plus C A XOR B whole thing bar. Okay, if you consider this, if you consider A XOR B as X, this looks like this, right? C bar X bar plus CX whole thing bar. Okay, this is actually an XNOR gate. Okay, an XNOR gate. So it will be C XOR X whole thing bar. Now double bar can be cancelled, so we will get C XOR X, which is equals to C XOR A XOR B, and finally we can say it is equals to A XOR B XOR C, and that is equals to S. That is what we needed. Only by using 8 NOR gates, we were able to come up with the full ladder sum. Just 8 NOR gates. Okay. Now what we can do, we can come up with the C out. C out is pretty simple. Okay. We are going to use A plus B whole thing bar. Okay. We are going to use A plus B whole thing bar, and then C bar into A XOR B. A plus B whole thing bar and C bar into A XOR B to come up with C. Okay, so I'm going to take a separate branch from here and a separate branch over here, and I'm going to draw a NOR gate here, and that will result in the C out, which is equals to A plus B whole thing bar in plus, okay, not into, plus is NOR gate, no into, C bar A XOR B whole thing bar. Now you may ask me, obviously, C out is AB plus BC plus AC. How did I even come up with this Boolean expression? Yeah, C out can be given as, I'm going to break this, so I'll get A plus B whole thing double bar, okay, dot, I will get C bar into A XOR B whole thing bar. This is equals to A plus B into C, let's take this, C double bar plus A XOR B whole thing bar. So this will be equals to A plus B into C plus, I'm going to break this down, which has AB bar, not AB bar, I'll be using, since this X now, I'll be using AB plus A bar B bar. Now this will be equals to AC plus AAB plus A bar B bar plus BC plus ABB plus A bar B bar. Beautiful thing is A bar B bar will be cancelling each other out. Why? A bar is equals to 0. Similarly, B bar is equals to 0. We can cancel this also down. Now we have AAB and ABB. This is also AB. This is also AB. And AB plus AB is equals to AB. So AB plus AC plus BC. That's it. We have done the C out also. Now this is the important things that you should know if you are sitting for the high school examination, okay, or the CA level examination. This is all you should know. Okay. But in the next video, I'll be talking about the ripple carry, and that is about how we can perform any two binary number addition. Okay, any two binary number addition. For now, we have been working with only 1-bit binary number addition with two numbers, with two operands. But in the next video, we will be talking about how we can rearrange this full ladder so that we can make multiple bit two operand adders. Okay, two operand adders. Okay, so that's it. I hope you understood this video, and meet you in the next video. Thank you for watching the video on how to make full adders by using only 9 NOR gates. If you found this video helpful, don't forget to like, share and subscribe for more lessons like this. I'll see you in the other video. Until then, keep learning and stay curious. Bye bye.